Now coming after defining these signals, this is a port list. Okay, so in port list, these signals will communicate with master state machine. So these are signals internal to the modules. Means not internal to the modules means these signals will not come in top module. Okay, so only UTMI pertaining signals will come in top module. UTMI application and processor interface signals will come. So these are internal signals. Okay, intermediate signals you can say. And these are some decoded informations. After receiving a packet, I have to decode the information. What type of PID it is? In out
PID.
Okay, then what type of then we have to take the address. Okay, so all those information we have to decode and we have to pass to master state machine. So master machine will take the control. Okay, so this then suppose we are receiving the data. During that time we have to give the data to application side.
That means memory.
That
means device specific logic and then getting the memory.
Right. Okay. In that, suppose that is a pen drive. After application, what it will do? It will take the data from the buffer and give it to the memory.
Yes.
And it is getting stored there. Token 2 register. Okay, 2 register I am defining. So how my frame looks? First I will get PID. Okay, then I will get address. Then I will get endpoint. And then CRC. So this is 7-bit, right? This is 4-bit and this is 5-bit. So this 7-bit plus this 1-bit, 8-bit I need na. I can store only 8-bit. Okay, so address is 7-bit, this is 4-bit. I can only take 1 bit from here and I can store here, right? And after that 3 plus 5 8 I will store here. Okay, you're getting. So how data is stored in this register, you see. So see, I am taking that thing in token 0 register. Okay, and other I am taking in token 1 register. Okay, now I will show you where I am decoding. Okay, first after getting a token. Okay, I have to decode now this information. Okay, so where to decode?
First we decode token 1.
First byte, first 8-bit I received in token 0. Second 8-bit I received in token 1 register, 2-bit register. Okay, now here I am decoding. See, I am taking token address. Okay, address is how many bit? 7-bit.
7-bit.
So I am taking that thing in 1 register, token address. Okay, endpoint is how many bit? 4-bit.
4-bit.
Right. 1 bit is stored in token 0, right? And other is stored, other 3 bits are stored in token 1. So I am using concatenation operator and I am giving that to token endpoint. Okay, then token CRC I am storing here. Okay, 5-bit CRC. So I am storing in token CRC register. Okay, this is 5-bit. And this is frame number. Frame number you have seen, one field is there. Okay,
Frame number.
this is a field in USB. How many frames we have transferred? Okay, so during start of frame, when start of frame flag will come na, during that time this. So right now this thing is not required. Okay, right now you assume those things only, whatever I explained you. Okay. So now address is in this register, token address. Token endpoint is in this register. Okay, now I have to check whether these things are corrupted or not, right? For that I am calling the CRC module. Okay, fine. CRC is used to check whether your input data is corrupted or not. Okay, so for that I am passing, this is my initial divisor. Okay, this is algorithm. Okay, so now token address. So what all things I have to pass? Address and endpoint, right? On this only I will calculate CRC, right? So I will pass this information with inputs information, and based on that it will give you CRC out. So what data I have received, based on that I calculate CRC here. So that is stored in CRC out. Okay, then I will check with expected. Okay, so that I will check. Okay, I am concatenating. See, so 5-bit CRC na. Okay, so this. So where I am checking here CRC error. If token CRC 5 is not equal to CRC out. Okay, CRC out, this is the CRC which we calculated on the received data. Okay, and this is the what we are assumed. When both are equal, then there is no error, right? When there is mismatch, then only there is error. Then CRC error flag is asserted. Okay. See, now CRC out 2 we calculated on incoming data. So incoming data is stored in this token address and token endpoint. Okay, and when you are transmitting, during that time you calculated on a CRC. Okay, and after that, after calculating the CRC on this, I will compare that with the expected. See here, token CRC 5 here also. See, getting here we have already received the CRC information. We calculated on this. If both matches, then there is no error. If both don't matches, means there is an error. Okay, so CRC is created, clean. You got. So we have decoded all the information pertaining to token packet, because first token will come na, then data, then handshake. This is the mechanism, right? So right now we have only decoded the information related to token packet. Now we'll see data packet. Okay, now assume that there is out transaction. Out transaction means host is sending the data. Okay, you assume. Now we'll see how we are getting. Now if UTMI TX valid is high and UTMI active is high and not of error, so I am loading second register. Okay, 2 tokens are there na, so I am coming after that. After receiving, I am going to idle state. Okay, else if error is there, so I should go to idle state. Okay, now coming to data state. In data state, I am checking this valid, active and not of error. Then I am enabling this state. Okay, high, and this is logic. Data done. After receiving the data, I have to enable one signal, data done. Okay, if error, if active is low in between, so I have to go to again to idle state, else I have to take the data. Okay, so this is specific logic, means you can say that implementation dependent. Okay, so just to see the logic how it